All right, for number 3, we're supposed to write an expression for x sub I in terms of I and n. All right, so here's our number 3. What does x sub I equal? Well, so the I is the subscript of the x, right? So this is I equals 1, I equals 2, I equals 3. When I equals 1, xi is 2 over n. I equals 2, we have 4 over n. I equals 3, we have 6 over n. So what does x sub I equal in terms of I and n? It's equal to 2i over n. All right, next we are supposed to, for number 4, it says write an expression for f of x sub I in terms of I and n. So let's get f of x sub I, and I'll leave that to you. You can take a pause and come back. All right, here we're looking for f of x sub I. F of x is equal to x squared. So f of x sub I is equal to x sub I squared. Right? F of x squared, f of x sub I squared. All right, but what's x sub I? It's 2i over n. So we're just doing a substitution here, 2i over n squared. All right, now as we go along, we're going to want to simplify things as much as possible. So this is 4i squared over n squared. All right, number 5. 5 says a sub I equals f of x sub I delta x. Write an expression for a sub I in terms of I and n. So a sub I equals f of x sub I delta x. This critically important fact appears here. It appears here. It is the essence of this whole thing because it means the area of each rectangle is the a sub I is equal to the delta x, the width, times f of x sub I, the height, right? That's true of this a sub I rectangle. It's true of all of the rectangles. Every rectangle is a width of delta x and a height of f of whatever x you're on. That's the x sub I. All right, so every a sub I is f of x sub I delta x. You have an expression for f of x sub I right there and an expression for delta x right there, so you do that. All right, hopefully you've had a chance to do that. F of x sub I is 4i squared over n squared, and delta x is 2 over n. So this gives you 8i squared over n cubed. Yeah? Okay, let's bring that over to the next page. We're saying that a sub I equals 8i squared over n cubed. Okay, now it says, substitute your expression for a sub I in the expression below. You should go ahead and do that. It's easy. Okay, so hopefully you have the area from the right-hand summation is equal to the sum from I equals 1 to n of a sub I, which is equal to the sum from I equals 1 to n of 8i squared over n cubed. So it's just a matter of putting this where that is. All right. Now, the power of this, where we're getting to, is this is a formula, a summation for any right-hand sum. Oops, sum, all right, with n rectangles. So by not having specified the number of rectangles, that's going to allow me to use the limit on that expression for n. Now the problem I'm still faced is I can do a limit as n approaches infinity, but not with this sum sitting here and not with this I squared sitting here. So my next set of steps is going to be to get those out of there so everything is just in terms of n in an expression that I already know how to do the limit of. So let's see what's next. It says, from your summation above, factor out all terms in n and use a formula to convert the summation in I to an expression in n. I think actually factor would be a better word here than terms, but it comes out kind of redundant. No worries. All right, so in number 7, before you try that, I want to give you a little bit of background. Number 7, some background. Now we're going to do a lot at the end of this course involving just working with sums, working with summations, like a lot. So it's good to be, conscious of those as we go along, some properties that sums have. So we need a property of sums. If you consider the sum from I equals 1 to n of a x sub I, all right, where a is just a constant, a real number, a constant. And the x sub I is all dependent on I. Okay, then what this is equal to is it is equal to, what is the meaning of this summation? It means ax1 plus ax2 plus ax3, etc., up to axn. That's what this summation means, all right? Now, since I have a summation that's just a finite sum, it's really just a polynomial, right? I can factor the a. Is it a polynomial? You have to think about that for a while. All right, I can factor the a out of this expression, whatever the heck it is, and get x1 plus x2 plus x3 plus up to xn. So the reason that I find that interesting is that this is just the sum from I equals 1 to n of x sub I, and I've brought the a out. So what it really comes down to is that you can factor a constant out of a sum, right? So we know that the sum from I equals 1 to n of a x sub I is equal to a sum from I equals 1 to n, sorry about that, x sub I. All right? So this is just a formula that says I can factor a constant out of a sum. Maybe that's obvious, but you know, nothing is really entirely obvious, and I think in this case it bore some prior thought. Okay? So now we're going to take our sum 8i squared over n cubed from I equals 1 to n, and we're going to do that to it. What can we pull out? We can pull out the 8. We can also pull out the n cubed because n, while it's a variable with respect to the top of this sum, it's actually constant with respect to the n rectangles. So if I specify 10 rectangles, this is just 10. So the n is constant with respect to the true variable of the problem, which is I. The variable of summation is I, and the n is just a constant for this sum. So we can factor out the 8 and factor out the n cubed. Do that, see what it looks like. Okay, so what it should look like is 8 over n cubed sum from I equals 1 to n of I squared. Now, so what? Why is this getting me any closer to being able to apply the limit? Well, I'll tell you why. Remember this? Remember that guy? The sum from I equals 1 to n of I squared is equal to n plus 1, 2n plus 1 over 6. So the power of this is it takes a summation with an I squared and turns it into a rational expression in n. Summation with I squared, I don't know how to do the limit as n approaches infinity of that. But a rational expression in n, I do know how to do the limit. And these two things are the same. That means I can replace this with this. That's what we're going to do now. So this sum equals 8 over n cubed times n plus 1 times 2n plus 1 over 6. So that is equal to the sum from I equals 1 to n of a sub I. This, in fact, is our right-hand sum with n rectangles, but now that sum depends on nothing but n. So that means I'll be able to take the limit as n approaches infinity. So your next job is to simplify as much as possible. So simplify this as much as possible, and if you're really ambitious, jump to part 2 and find the limit as n approaches infinity.